Set up an integral expression for the arc length of the curve given by the parametric equations x equals t squared plus 1 and y equals 4t cubed minus 1 from 0 to 1 when you're looking at the interval for t. So the integral expression, the actual formula, we are integrating because we're adding up a bunch of tiny itty bitty bitty lengths, and it's from some given time a to another given time b, and it is the square root of dx dt squared plus dy dt squared. All of that's with respect to t, and if this looks like the Pythagorean theorem, you're correct, it is. We are actually looking at little itty bitty vectors, and we're figuring out what's going on with that. So if you have some point here, you have a dx dt, something going in the x direction from that point. The dy dt, you have your little vector going in the y direction from that point. And to figure out the actual length, I'm going to do a head to tail right here with the vectors. I'm finding that length right there. So I would use the Pythagorean theorem. But I'm trying to find length from velocities, from a dx dt or dy dt, from a rate of change. So we are integrating that from a given time to another given time. And when we actually do this with non-parametric equations, because we will be doing arc length again, we'll go through all of these steps in detail. So for this problem, it's very simple. Our given time is from time equals 0 to time equals 1. So those will be our limits of integration. So we'll integrate from 0 to 1. And then we have the Pythagorean theorem. Then if you look what's inside of it, you have a dx dt squared, so you do have to take the derivative of x, which is 2t squared, plus the dy dt, that's the derivative of y, so 12t squared. And then we will be squaring that, and this is all with respect to t. And most of the time on the AP test, you'll be in charge of just setting up these integral expressions, or you would have a calculator, and the same is true when you're taking one of my tests. But the reason for that is if you look at your actual integral expression, this would normally be a u sub. If you look at the square root, you see the inside parentheses right here, and this could be your u, but you have things that are squared, and you have a t to the fourth over here, and there are no t's outside of the square root. So a lot of the time, unless this can be simplified with the square root, you actually do not have a method to take the antiderivative, so you can't do this by hand. It's not to say that you always can't, because if the interior of your square root simplified down so that you could take the square root of it, it would be totally possible. But most of the time it will not, so you'll either have the calculator or you'll just set up the integral expression.